Hello guys. In this video I'm going to talk about tension in some strings that are holding a sign that's not moving. Okay, so I have a picture here of a sign that has a mass of 20 kilograms and it's being held by two strings that are vertical. So I'm going to try to draw the forces acting on the object here. So I have my mg and I have the two tensions holding it up. And the holding it, since they're both vertical, they are equal. So if I look at this picture here, there is nothing happening side to side. I only see things happening up and down. In other words, there are no forces side to side. So here I can say, you know what? The sum of the forces in the y direction equals ma. In other words, that's F net equals ma. Well, A is in the y direction, which means that since this is not moving, it just means that the A in the y direction is 0. So this is pretty much 0, which means the sum of the forces in the y direction is 0. Or in other words, the forces in one direction are equal to the forces in the opposite direction. So I see a T and a T in this direction, so 2T equals mg. Well, 2T equals, that's 20 times 10, so that's 200. So each tension here is 100 newtons. Now let's look at an example where the object is being held by strings that make an angle. So I'm going to make this 50 kilograms. And here is a string here. Here's another string here. Here's the ceiling or something that's holding it together. Okay. And I made the example already. So I'm going to say this angle here is 30 degrees. And this angle here is 45 degrees. Yeah, okay. You can see that this string here on the left that I'm going to call string 2. So now I'll call this tension here tension 2. And I'll call this tension 1. You can see that this string is more vertical than this one. So which means it has to support more of the 50 kilogram. So when we're done, this tension in 2 has to be greater than the tension in 1. And this is the tension in 1. And you have your usual mg. Well, each time we have forces that are acting at an angle, we have to break them up, right? So the goal here is to find the tension in string 1 and the tension in string 2. And since the angles are different, those tensions have to be different. If the angles were the same, the tensions will be the same. All right, so let's see what we can do here. Let's concentrate on the x direction. So before I do anything, I have to take this force here, this tension, and break it into components. So this is T1 in the x direction, and this is T1 in the y direction. Now, if we look inside this triangle here, you should be able to see that T1x is the adjacent to the 30-degree angle in this triangle. So that's basically going to be T1 cosine of 30. If you can't see it, you can do cosine of 30 equals T1x divided by T1, which is the hypotenuse. T1y is the opposite from the 30. So it's going to be T1 sine of 30. And we'll do the same thing on the other side. Okay, so we're going to go left and up. So this is T2x, which is basically T2 cosine of 45. This is the adjacent to this angle, and this here is the opposite. So this is T2 in the y direction, which is basically T2 sine of 45. If you can't see that, you have to review your trick, or just write sine of 45 is the opposite over the hypotenuse, and you can take it from there. Okay. Now, if this sign is not moving side to side, and if it's not moving up and down, it means that the forces to the right and the forces to the left are equal, but also the forces up and the forces down are equal. Okay? So once I break down these T1 and T2, I no longer look at them. I just look at their components. So I can say, you know what? This T1 cosine 30 is equal to T2 cosine 45. And I can say that up, everything up, and when I say up, I mean straight up, equals down. So it should be T1 sine of 30 plus T2 sine of 45 equals the mg. Okay? Now, the mg is just 50 times 10, so maybe I can replace that with 500. Okay? Now, how do we solve this? Well, this is a system of two equations. Okay? Okay, so I'm going to try to isolate T2 here and plug it in here. So let's see if I can do that quickly here. So I'm going to take this here, divide it, and do a little substitution. So instead of writing T2 here, I'm going to write that instead. So let's see what it looks like. So it's T1 sine 30 plus, I'm not going to write T2. I'm going to write this expression for T2. So that's basically T1 cosine 30 over cosine 45. And don't forget that the sine of 45 is still there, equals 500. Well, I did the math, so this is what I got. I got 0.5 T1 plus 0.866 T1 equals 500. And if you do the math correctly here, you get T1 to be 366.02, I think, newtons. Now, to find T2, I just go back to this equation here. And I plug in the 366 in here. And I should get a value for T2 equal to 448.29. Okay? And some of them are easier than this, especially if the angles are the same. And that's pretty much how you solve problems where you have to find the tension in the string when something is hanging on the strings. All right? I'll see you later, guys. You take it easy.